Hi. Exam 1 review. Yes, no one is happy, right? It should be like happy times, right? You get to show off your math skills, but then, hey, you wanted your test, so let's go. Chapters 6 and 7. Why is this red now? Chapter 6 plus chapter 7. 10 problems for 80 minutes. That's hour and 20. There's usually a 5-minute break, so you can, work through the break, hour 25, whatever. I already mentioned that every other page on the exam will be blank, so exams are not printed on both sides. They're printed on one side so that you can use the other side as a scrap paper. You can use the other side to calculate it, to check your integrals, do the derivatives, as I mentioned in a previous lecture. And you can also use it to be creative, draw something nice, or write a short story, a poem, or something. It's all good. So 10 problems, 80 minutes. Now, what's on the menu? Well, we are going to have, let's go, number 1, disk slash, area between two curves. Area between two curves. Then we have disk slash washer. Then we have shell. After that, we have length of curves. Number 5, surface area revolution. Number 6. So what else is cool? So we have those problems in physics, but I'm just going to pick specific ones. So you don't have to worry about all of physics, just, some, so you can at least enjoy a little bit. We'll do the mass, which was the integral of density, and we'll do the spring in parentheses work done by the spring, where you have to mess with those limits or something. All right, that's good enough. Number 7, exponential logarithmic derivatives slash integrals. Number 8, exponential models, which is word problems. Number 9, hyperbolic functions. And I'll say pre-calc plus calc, because remember, the pre-calculus would have the proofs and all that good stuff, and the calculus had the derivatives of these. Yes?
So have water pump problems or pump problems in the physics portion?
Would you like those? I can add.
Oh, no, I'm good.
For the moment I thought you were suggesting to add them. All right. Would anyone else would like to add those problems to the list, because I can write them in? All right, fine. Be like that. All right. We understand that all of these, with exception of 7 and 8 and 9, are all integration, right? 7, 8, 9 also have integration, but they also have derivatives as well. So integral, and most of these are definite integrals, which have limits, right? So plus c integrals will be rare. You can encounter plus c integrals under hyperbolic functions. It's a, just the integral of whatever. But all of the applied integrals are always with limits because you are calculating something. You're calculating work, calculating energy, calculating area. You're calculating something tangible. So most of the integrals will have limits which you have to compute as top minus bottom. Formulas are something that you are learning. That is your learning objective for this, because you didn't learn any integration. Integration is the recycling of the Calculus 1 basic integrals, U sub, and some of those algebraic manipulations as we saw earlier in 8.1. So, area between two curves, integral a to b, you have f minus g dx, let's say. Disk and washer, integral a to b, you have f squared minus g squared dx. Shell, there's a pi over here, there's a 2 pi for shell, a, b, and we have position, so p of x times height, h of x, dx. Length of curves, L equals integral a to b, square root of 1 plus f prime squared dx. Now all of these could be in terms of y, depending on the rotation and all that. Surface area of the revolution is 2 pi integral ab f of x times square root of 1 plus f prime squared of x dx. So far, that's 5 formulas, but then they all have their y equivalents and so on. So it's not 5, it's 10 formulas, right? But it's all the same, just replace all x's by y's. Physics, we said that the mass is the integral of density, and we said that the work for the spring would be AB force times x dx, right, from the Hooke's law. Then whole bunch of formulas, exponential, logarithmic, exponential models with word problems, and then you have those 6 hyperbolic functions, and with those 6 hyperbolic functions you have derivatives, you have integrals, so you are technically learning the whole spiel. Some problems will say use blah blah to solve a problem. Some problems will just say integrate or calculate the volume. If it says calculate the volume and you see it's an object that because it said revolving around x-axis or y-axis, you know it's a rotation problem. You will have to choose which method to use. So some problems state use shell method, right? Or use washer method to do blah blah blah. But in other case, we just say find the volume as the function blah 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 rotates around, let's say, x-axis, and in that case you see which fits the best. So the word problem depends on, which one. I mean, this exam is tomorrow, so I have plenty of time to think. Wow. I might give you the model and ask just to do calculus, or you might have to, crank the pre-calc from last time, from yesterday, and then, not from yesterday, 2 days ago. Crank the pre-calc to come up with a model, and so that, it all depends on what type of question. I might give you a model and then ask you to tell me, the calculus aspects of that model, which is the derivative, the limit, derivative, and integral, and what they compute in a context of the problem, of the word problem given. So there are a few combinations that we can use to come up with a problem for that. Bueno? Yes?
So are these like problem number one, problem number two, or is this just topics?
No, because I have to fit them on the page. Some of these are long calculations, some are short. So whatever fits, like a Tetris pieces, you know.
Okay.
So you might open with 6,
Okay.
followed by 8.
So like it's going to be one problem with say everything goes, one problem with shell was it doesn't matter.
I don't know.
Okay. Good enough.
It's tomorrow's problem, man. It's too early for me to know that.
Before the test.
Do what?
Are you going to make the test right before the test?
No, I will make the test either tonight or tomorrow morning, but it will be copied right before the test, yes. You know what the Murphy's Law says, that, everything that can go wrong will go wrong? Yeah. I'm the only one who's always panicking around the copy machine because the exam started like 10 minutes ago and I'm still unjamming the damn thing. But the great thing is that all of the machines are new, so no issues.
Don't you say that.
I just did. I realized then, yeah. So, at least one problem each section, but then you see the list of these hyperbolic functions can have, right? A proof as one problem, and then, I don't know, integrate integrate, yeah, why not? Integrate secant 3x tangent 3x dx. Why not? So that would be a problem, that would be hyperbolic, and then put in some limits as, I don't know, ln of 3 and ln of 7.1. It's limited to Calculus 2, so you do not have to worry about nuclear physics or rocket science or anything. None of that will be making appearance on this exam. It's just calc we did here. But it depends heavily on your ability to integrate in U sub, and obviously, which is your Calc 1. And if you took Calc 1 with me and U sub and all these are not there, there might be some change of grade updates. Drop the course. Any other questions, concerns? So, no cell phones. Bring in either basic or scientific calculator. Most likely you won't need any, but security blanket is security blanket. And no graphing calculators, we said that. No bathroom during the exam, that should be common sense, so go before or after. Bring some water or sugar to keep you going. And sleep. Oh my God. There's nothing worse than you stay up all night to study for the test, and then you study tomorrow all day before the test, and then you show up brain dead because you just exhausted all of your resources, and at 4:30 here you're like a zombie with those red eyes, and you can't. And then you fall asleep during the test, actually, because you've been on those energy drinks all day, so you just crash. If you don't know it by now, you can't learn it for tomorrow. That's simply what it is. You are just entering right now in the review mode to just make sure that you don't forget any of the formulas. But if you spend your night and a day tomorrow studying, you're going to confuse all of these formulas, because brain is a part of the body. I mean, you don't see athletes, getting ready to run the marathon, run for 3 hours, right? And then go and line up to run marathon. Well, you're tired at that point. You can't run anymore. So it's the same thing for, attention span for study. Depends, person to person, but it's 3 hours at most. You tell me that you studied 6 hours. You at best studied 2 hours and wasted 4. That's the most. And I know that because I'm good at it, right? And I had 2 rules. Never longer chunks than 3 hours, and never study when it's dark outside. Those are the 2 rules I had in my education, because they're never productive. In my case, they were never productive. So only study when it's daylight, and only study when up to 3 hours in one shot. And then play video games, go outside, do anything else. And if I feel like it, come back later and do more. But most likely, and if you can't accomplish any stuff in 3 hours, then most likely you won't accomplish it in 20 hours. So small increments of time. That's why those quizzes are so damn good, because you get to log in every day in small chunks. Just the way you eat. You know, you eat every day small portions, right? You don't store the food in the fridge for a week and then you sit on Sunday at 5 p.m. and then you eat for a week, right? Can you imagine that? No. You sleep every day, you eat every day, you go to the bathroom every day, right? So the brain is the part of that machine. Small chunks every day and you have no problems. As soon as you put everything away for a Sunday, and you're just going to say, okay, yeah, I got this, because exam is tomorrow, it's all-nighter tonight. It's not a quality knowledge. I told you that you're going to use this for differential equations. Can you memorize these formulas for tomorrow? Sure. Depending on how your brain is wired, you might be able to recall all of them, even though if you're tired. And pass the test. You know that DFQ is coming up, right? You're going to remember it then. There's a difference between quality knowledge and then just this thing that you did for exam, which is pointless. So, unless Calc2 is your last course in math ever, you have nothing to worry about ever again, ever in any other course, then no one cares. Do whatever the hell you want, right? If you're taking DFQ, you don't know these things, it's just going to be terrible then. Then you have to learn 2 courses because you have to relearn Calc2. You know right now if you are burning. I don't know yet, because half of you I don't know. I didn't have you in my Calc1. But if you were looking at those integrals in 8.1 going, what the hell? Well, you know the way the Calc1 went in that case. Because if the Calc1 didn't go well and you don't know them, you can't know them now. So now what do you have to do? Relearn Calc1, basic and use subintegrals, and on top of that, all of the red stuff and how to apply it. So you're learning 2 courses. And let's say by some miracle you make it through Calc2 in differential equations, now it's compiled, right? Compound interest, right? For DFQ, because you have to relearn Calc2, and Calc2 uses Calc1, which is why someone says, why can't we have formulas? Really? Since algebra, you get formulas? Sitting in Calc3 with the book of formulas, that it's 3 inches tall, scroll, right? Shoveling 2 pages to see what happens when you add exponents, right? You see the way it goes. It just, there is a point at which you need to know something. So sleep tonight well, be rested, so tomorrow you will be easier for you to recall answers. And again, if you study tomorrow 6 hours because you took off work to study for the test, well, you're going to show up here at 4:30 and you're going to be brain dead, and the score is still going to be 38. Good night of sleep. Don't overexhaust yourself tomorrow. Get, food in your system. Leave earlier than usual, so you're not driving like a maniac, stressed, get in an accident or something, or worse. So all of these factors are there for the test. And then when you're here at the exam, test taking skill 101. Read the whole test before you solve anything. You pick out those problems that you can solve like this. We're all wired differently. What's hard for some of you is going to be joke for others, and vice versa. So you will find maybe problem number 3, problem number 6, and problem number 7 are something that you can solve without thinking. Boom. 3 out of 10 done in the first 5-6 minutes. Then you go back, you solve something else, you can have half of the test done in first 20-25 minutes like this, if you are now if you go and you just look at the first page, and let's say on the first page you have, I don't know, spring problem, and you stay with the spring problem for 40 minutes, right? Then where's the rest of other 40 minutes for other 9 problems? Because I was 1 to 9 a good ratio. I mean, yeah, 1 to 9. So rest, eat, get the energy, don't exhaust yourself, don't stress yourself by trying to rush to class because you left late or something. And if you're here an hour early, you still have time to talk to Evan and, iron out if there's anything else really burning right at the end. And then you should do well. You should do well. Do you have any problems that need to be solved? Rotation, area between two curves, volumes, yes.
Can we do an example of it?
Example, yes. Which one?
Oh, no, I mean, like, we don't have to go.
Yeah, I know. Which one?
10 in math class,
Which is what?
which is in the year 2000, the population of a certain country was 284 million.
Okay, so year 2000, population was 280 million.
84 million.
84 million.
With an estimated growth rate of 0.4% a year. So A says, based on these figures, find the doubling time and project the population of 2000.
Doubling time, and then population in 2100. You're not going to last that long, but that's okay. Hope wishful thinking is always good, right? All right. The rate of 4% growth, 0.4% growth in a year. So the first thing I'm going to do is I'm going to set that the year 2000 is t equals 0, which eventually will say that the year 2100 will be t equals 100. So that's the first thing that I'm going to set, so I have that as a reference point. Then, if population in year 2000 is 284 million, that's my P0, initial population 284 million is this. Now, I need to calculate the increase of 4%, which will give me the new data point, so I can calculate, right? So 284 million times 1.004. So this is 10%, 1%, and then 0.1%. So I am increasing this number by this much, so I need to have this 1. Now you can also multiply by 0.04 and then add, but this is doing it in one shot. So the population in a year 1, which is year 2001, for t equals 1, population will be 284 times 0.004 284 times 1.004 is, I can't type, 284 times 1.004, there we go, 285 0.136, so I'm just going to say 0.1 million population. So now, I have the population model, e to the kt. I know population is growing, so I'm looking for positive k. That's just keeping back of my mind. P equals, initial population is 284, e to the kt, and now I'm going to use 1, 285.1 as a point to calculate t, because this is the next year's population, right? Because the rate of growth is 0.4%. So going from the 284 million to 285.1 million people in that country, we have a new data point that we can now calculate. 285.1 equals 284 e to the, now t is equal to 1, so it's just e to the k. So now when you divide 285 by 284, you're going to get that 1.004 equals to e to the k. You ln both sides, and you get the ln of 1.004, which gives you that the k value is, which is the growth constant, 0.004 decimals, 3992. Now this gives you the population model of 284 e to the 0.003992 t. This is your model. Now you get to answer the two questions they asked. The easier question is, what's population 100 years later? Well, you will plug 100 for t. So we have p of 2100, so that's 2100 year, which is 284 e to the 0.003992 times 100, because t is 100. So population in T100 of that country will be 284 raised to the, no, 284 times e raised to the, and now you can multiply by 100. That will knock off the two decimals, right? Move to decimal two places, so you have 0.3992. And we get 423.3 million. Your base number of 284 was given with no decimals, so your calculation is allowed to produce one extra decimal. If you took any physics or chemistry, right, you know that your calculation is allowed to just produce one more decimal place. Except if it's money, you are allowed always 2 because cents, right? If you talk about people, now this is millions of people. If you talk about people units, then make sure you use a whole number. Don't give me an answer of 7.3 babies. It's either 7 or it's 8. 0.3 of a baby, not too good. Well, cries less, but. So, yeah, that's true. So we have 423 million in 2100 for the population if this country is to survive that long. Now, we also have the doubling time. Doubling time means in what year you are expecting to see double population, right? So if you are starting with 284 million, you want to see double population, so this is times 2, so 568 on this side, and then e to the 0.003992 t. T is a variable. Now the greatest thing about this is that actually you do not have to put these numbers in, because it doesn't depend on the population. It depends on the rate at which population is changing. That's the key, right? It doesn't matter how many people you have, it's at the rate in which people multiply. So you can actually have a p and 2p, it will be the same, because they cancel to 2 on the left-hand side either way. So whether you have a p0 and then 2p0, p0s cancel, you get 2 on the left. If you have 284 and 568, they still cancel to 2 on this side. I'll explain this concept using a different example. If the rate at the bank, rate of increase in the bank, right, is a certain percent, and let's say it will double your money in 10 years. So let's say there is this insane percent in a bank. You put money in savings. It doesn't matter how much money you put, because the rate is the one that will impact the doubling time. So if you go to the bank and you put $1, in 10 years you'll have $2. If you go in and you put $1 million, in 10 years you have $2 million. See that? So that's the doubling rate. It doesn't depend on how much money you put in, doesn't depend how many people you have, right? It's all about the growth rate, and then that sets how long until it doubles. You can do the triple, you can do whatever, right? So now all you need to do is to ln both sides, and you have your answer quickly. So you calculate ln of 2, and then you calculate and you divide ln of 2 by this decimal. So ln of 2, 0.6931 is equal to 0.003992 t, and then t is equal to, divide by 0.003992, 173.6. These are all approximations anyway. So you can say in about 170 years or 175 years, we are expecting to double population. So the number you get there is the number of years since 2000, 2174. That's when you have double population. Cool? Of course, cool, man. Anything else? No? All right. Hasta mañana.